Now, as we mentioned in part one of our recording, Civil AccuDraw allows you to do really two things. Number one is to communicate precision input. In other words, it allows us to provide point input such as coordinates, distance, direction, station, offset, etc. to any microstation or civil command or construction which requires a point. The second thing it allows us to do is to communicate design intent. In other words, civil commands can persist the Civil AccuDraw input as rules on the points. Now let's look at the first one of these primarily, and that's precision input, providing that point input to any microstation or civil command. I want to look at a few examples of this. The first one, we'll look at horizontal geometry, for example, maybe right-of-way, where you might want to use Civil AccuDraw to place existing right-of-way using coordinate XY information into the elements by PI command. Or maybe you want to place some easements that are based off the existing right-of-way, and you want to use some station and offset input, and then when the right-of-way updates, the easements will update automatically. Or you might use Civil AccuDraw to place parcels using XY for points, or using distance and direction. So let's look at this first example, and let's just look at placing some existing right-of-way. So I'm going to go select a feature called Geom right-of-way, and that'll just set up our symbology. Notice I've got Civil AccuDraw ready to go, so I'm going to activate it, and I'm sitting there in the XY methodology or mode. And so you can see that comes up, and notice that just using the tab key to move between the different fields in the cursor prompt dialog. So I'm going to begin by giving a specific location where I want my first point to be. And I'll just key in an XY coordinate. And again, by hitting the tab or the enter key, it will lock that in for me. Now that first point has been placed, and so now it's looking for a second point in my, again, remember I'm in my complex by PI command. And so I'm going to put in an X coordinate for my next point and a Y coordinate for my next point location. And then before I place that next point, I'm going to put in the radius that I want to turn, in this case 1909.86. Now it puts that in for me. It's waiting for another point. Again, instead of me just a data pointing on the screen somewhere, I'm going to put in a specific XY coordinate. So for example, as a user, I might be sitting looking at some old plat map or possibly looking at a deed, but I've got some specific information that I want to recreate, and so Civil AccuDraw allows me to communicate that specific information to my civil command. Again, I'm going to put in one final point here. We'll put in an XY coordinate, and since this is my last point, I will just enter a radius of 0, and we will hit a data point to accept that, and my existing right-of-way will be placed. Now that's in there. Now let's say, for example, I wanted to go in and maybe do some parcels or some easements. I'm just going to go change to a different feature here called property line. And again, I could be doing some property here. I could be doing easements, any myriad of different things. I'm going to go over to horizontal geometry. Now notice that we're in a station offset mode, but in order to use station offset mode, I have to identify the alignment. So I'm going to use the O key on my keyboard, move over and select the alignment that I just placed, and now it's going to allow me to do station and offsets. And so I'm going to key in a station of 10 with an offset of -100, and I'll hit a data point, and that'll be my starting point, and it wants to know where's your next location. So I'm going to go to station 15, and we'll use the offset of 100 again. We'll just maintain that. And where's your next point? And so again, we'll keep 15, and we'll just go out a little bit further at an offset of -200, and that'll put in our third point. And then we'll just do something simple here. We'll go one more, and we'll go down to station 25 plus 00, and I tell you what, let's maintain the offset of -200. We'll hit a data point. And again, that's just an example, again, of using different types of information. In one case, XY coordinates. In the other case, station and offsets, to feed information into a civil command and allow us to do precision placements. You can do the same thing, for example, in profiles. Let's say, for example, you've got profiles that you want to place special ditch grades in. You might use that or do that using station elevation mode or station slope mode. Maybe you want to do subsurface design profiles using the profile offset mode of Civil AccuDraw. Or maybe you want to put in some bridge deck clearances using a profile offset or a station with a delta Z. So let's look at a couple of examples here. You can see here I've got an alignment with a profile view up. I'm going to expand the profile view, so you'll notice my focus now is in that view. So I'm going to open Civil AccuDraw and I'm going to dock it, and because I'm in a profile view I get profile options. So for example, one of the options I get if I go up and do any command, you'll see this here, is I get station and slope. I can move down and change that to station and offset. So let's use station slope and station offset to input some values. So let's start out. Let's just put in a station of 2 and an elevation of 740, and that puts in my my first data point. I'm going to go down to station 10, and let's put in an elevation of 755, and there's my second point. Now that I've got my second point in, let's change our mode to a station and slope. And so you can see here it's changed that for me. So let's move down to around station 16 plus 00, and let's do a slope of minus 4%. And so you can see that it's put that in for me. And we'll do one final one here at the end. We'll go back to the station in Z mode, and we'll put in a station of 23 plus 00 and an elevation of 720. And there's our special ditch grade. You can see now I've got individual pieces. I'm just going to complex this into a singles profile. And we've done that. Now if I select it, it's a single profile with all your element handlers. The last thing I'm going to do is I'm going to name this, and we'll just call this Special Ditch 1. So again, another example of just using Civil AccuDraw to feed input to profile commands in this case. Now another very useful methodology or mode of Civil AccuDraw is the profile offset command. So I'm going to come up and do a profile line between points again, something very simple. And notice that the station is being read from the alignment, but it wants to know the profile you want to offset from. So I'm going to hit the O button on the keyboard just like I did earlier in horizontal, and I'm going to identify that particular profile. And when I do, now the software knows, oh, you want your offset to be measured from that existing ground. So I'll come down, for example, to station 4 plus 00, and I'll do an offset of minus 12. And so it knows at that location, I want to hold that point 12 feet below the existing ground. Let's go down a little further to 17, and let's go 12 foot above the ground. And so again, nothing particular here we're doing, just showing you how to use the profile offset command to feed input into the vertical civil commands. So again, why do you need Civil AccuDraw? Well, hopefully you can see how useful it can be to allow us to provide precision input into commands. Now, the second reason that we need Civil AccuDraw is to communicate design intent. So what is design intent? Well, design intent is the act of preserving the rules and relationships created during the design process in order to maximize the downstream benefits of automated updates. Well, what do we mean by that? Well, just think about it. Everybody wants software that's going to automatically update the design whenever you make a change. And they want this because they think it'll eliminate errors. But if it's not done correctly, what most people don't think about is that automatic updates can generate just as many errors and omissions as they eliminate. And the reason for this is simple. If you're going to update a design correctly, the software has to remember the engineering decisions or the design intent that originally went into the creation of the elements and components. Because if you don't, then any updates you do are just going to involve assumptions or guessing, and that's going to obviously lead to errors and omissions. So how do I communicate to the software what I'm intending to do? And that's really the key to using design intent properly, making sure that as a user I have the ability to store rules and relationships that communicate how I expect that design to update. Now, I said all that, but it's probably a little easier to show it to you. So here is a video of a very simple intersection that I've designed with open roads. And you can see here my curb return radius is designed with open roads. I can change it. For example, the pavement I can change from 12 to 24. And everything is in a relationship with everything else. So for example, if I pick up the center line and move it, notice the edge of pavements move, the curb returns move, they maintain the trimming that they've done between the edge of pavement. Now that's all great. But what if I want to place a stop sign? Now today what you and I do is we place stop signs or something like this, and we'll just go in and put in stations and offsets and say, okay, I want you to put this at a station and offset. Now the problem with that is if I have to go move the alignment, the stop sign does not know what to do. It stays right at that same station and offset where you told it to go. So what I want to do is something a little smarter. So I'm going to place the stop sign, but I'm going to enable Civil AccuDraw with an offset mode. So I'm going to go up and identify the center line of the road and say, hey, I want you to be 65 feet to the right of that center line. And then I'm going to identify the edge of pavement from my other offset and say I want you to be 20 feet from that. Okay. Now, when I put that in, now notice if I select the stop sign, it remembered what I did. In other words, it used the Civil AccuDraw to bring that in. Okay, so now I can come in here, I can pick up the center line, and as I move the center line, everything updates. So think about your signing and pavement marking. Think about your curb cut ramps or your stop bars, things like that. Using them with Civil AccuDraw can build those relationships so they update automatically. And we'll look at other examples of this in part 3 of our presentation.